You can configure the internal server function through one-to-one NAT and NAT Engine series routers to protect data within the enterprise network and ensure internal server data is not exposed. First, let's see what the internal server function through one-to-one NAT is. In enterprise network scenarios, you can configure NAT so that users on a private network can access public network services. This hides the structure of the private network as well as devices on the private network. However, users on an external network cannot communicate with users on the private network. To address this problem, you can configure the internal server function on the private network. This function enables a NAT device to translate a public IP address to a private IP address based on a static mapping entry. The entry can map a private IP address to a public IP address, or a private IP address and port number to a public IP address and port number. The internal server function operates in either address-level internal server mode or port-level internal server mode, depending on whether port numbers are translated. Address-level internal server mode translates only IP addresses during NAT. In this mode, one public address is used by only one internal server. Port-level internal server mode translates both IP addresses and port numbers during NAT. In this mode, one public IP address can be used by multiple internal servers, which are identified by port numbers. The address-level internal server mode is also called the internal server function through one-to-one NAT. Now let's look at the networking of the internal server function through one-to-one NAT. An NE40E named NAT performs NAT to allow PCs within an enterprise network to access the Internet. NAT connects to an internal network through GE300 and connects to the Internet through GE301. The internal network segment of the enterprise is 192.168.0.0 with a 16-bit mask. The IP address of the internal server is 192.168.100.10. Only PCs on the network segment of 192.168.100.0 with a 24-bit mask can access the Internet. External PCs can access the internal server. 5 public IP addresses are assigned to the enterprise, 11.1.1.1 through 11.1.1.5. In addition, the enterprise's internal server has an independent public IP address of 11.1.1.100. The internal server function through one-to-one NAT allows an external host with an IP address of 13.13.13.2 to access the enterprise internal server. Before configuring the NAT device, let's look at the configuration roadmap. Step 1. Configure basic NAT functions, specifically, configure session table resources on a NAT service board. Create a NAT instance and bind it to the NAT service board. Configure a NAT address pool. Step 2. Configure mappings between the internal server's private addresses and public addresses. Step 3. Configure a NAT conversion policy. Step 4. Configure a NAT traffic diversion policy. Step 5. Configure routes to allow devices to communicate with each other. Let's move on and learn how to perform configurations on the devices. The first step for configuring basic NAT functions is to configure NAT session table resources. NAT session table resources are controlled using a license. By default, a device does not allocate NAT session table resources. You can adjust NAT session table resources as required. A VSUI 160E is used as a NAT service board in this example. Set the number of session tables that can be created on the NAT service board to 16 million in the license view. The NAT service board is installed in slot 8. Next, create a VSM-HA backup group and enter its view. Then bind the VSM-HA backup group to the CPU of the service board. Finally, create a VSM-HA service instance group and bind it to the VSM-HA backup group. The service board can be bound to a NAT instance only after the preceding configurations are performed. Next, let's see how a NAT instance is bound to a service board. As you can see, a NAT instance named NAT is created. After the VSM-HA service instance group is configured by running the service instance group command in the NAT instance view, the service board in the VSM-HA service instance group is bound to the NAT instance. A user table needs to be created for a user when the user accesses the internal server. By default, the address-level internal server mode is enabled. The public IP address in the user table is obtained from a NAT address pool. Next, let's configure a NAT address pool. Configure an address pool named Address Group A that contains IP addresses 11.1.1.1 through 11.1.1.5 in the view of the NAT instance NAT A. In this example, the address level internal server mode is used. In the view of the NAT instance NAT A, set the private IP address of server A to 192.168.100.10 and the translated public IP address to 11.1.1.100. As mentioned in the networking requirements, only PCs on the network segment 192.168.100.0 with a 24-bit mask can access the Internet. To implement this, configure an ACL. Create an ACL numbered 3001 and enter its view. Create ACL Rule 1 to allow only users on network segment 192.168.100.0 with a 24-bit mask to access the Internet through NAT. NET traffic diversion can be implemented on inbound or outbound interfaces. In this example, outbound interface traffic diversion is used. An IP address 12.12.12.1 is configured for the outbound interface GE301. Packets matching ACL 3001 in a traffic diversion policy are diverted to the NET service board. Next, configure a NET conversion policy. Run the NET outbound command in the NET instance view to divert traffic matching ACL 3001 to the service board for NET processing. Finally, configure routes to allow devices to communicate with each other. Create an OSPF process on NET A. Enter the OSPF area view and configure a network segment 12.12.12.0 with a 24-bit mask in the area. Device B connects to NET A through GE300. Configure an IP address 12.12.12.2 for GE300. On device B, create an OSPF process. Enter the OSPF area view and configure network segments 12.12.12.0 and 13.13.13.0 with a 24-bit mask in the area. Configure an IP address 13.13.13.1 for GE301 that connects device B to an external host.